Hello. I'm going to go about half way through, I think 10 minutes, no more. Um, and then I'll do, I think the second half will take another look. And then I'm going to post this on YouTube. Um, I will put the link, which you need to open in a separate window, but sometimes Canvas is very picky about that, and I will just uh, put the link that's not hot, but just where you can copy and paste the reference. All right, so solving right triangles means this. Here's a right triangle. Here's some parts of it. Fill out find all of the rest. So in this, all of the triangles are right triangles. There is no uncertainty about that, and I will just state one convention that I will always use angle C as I have to put a band-aid on. I'm bleeding on my keyboard. I will always use C, capital C, as the right angle and lowercase c as the hypotenuse. So that will be, okay. Okay, I'm back. All right, a few things that are not about triangles, or about right triangles in particular. Give a sketch of the triangle with all parts included. Angles or vertices, right? The corners, the vertices are all labeled with capital Roman letters, and then the sides opposite the angles are the same letter, lowercase Roman letters. How you identify angles inside is up to you. I don't usually do anything. Give angles in degrees just because it's easier to understand, and round to the nearest tenth as needed for the lengths. Unless it specifies to give an exact value, then it's the square root of 55, period. Show your work, give formulas, symbols, right? And words and symbols, show your work. I'm going to model your what is needed. So this is what it's going to look like. Here's what a typical problem looks like. Solve the right triangle ABC. So my convention is angle C is a right angle, always, and side C is the hypotenuse. Now that's a good hint for you to self-check, because if C is hypotenuse, it's the longest side, so you can see if your calculations are working out. Oh, one other piece of information that you have, or reinforcing it, the sum of the angles of a triangle is 180 degrees. All right. Okay, so here's side A is given, angle A is given, find all the rest, right? So angle C down here is 90 degrees. That's given. 90 degrees, we know that. So the question is, what's angle B? What's side B? What's side C? And again, I'm going to be very particular about labeling. All right, so you can see here in my diagram, here is side C. The right angle, this little symbol here is universally used to indicate right angle. This vertex, or capital A, side A, as specified, is 20 degrees. B is the vertex or the angle B, and capital B, and then here is the side opposite. Angle A is side lowercase a. The side opposite angle C is side C. The side opposite angle B is side side B. Okay, and then I filled in what I know. Angle A is 20 degrees, side A is 12 units. Now, here's another one of my requirements. It is that when possible, use what is given. If it is possible to use what is given, then use it. Do not use approximations or previous calculations. unless they are specifically in terms of what's given. So for example, tangent, and then SOHCAHTOA, well, you're welcome to use it, but uh, I, I expect that you write that the tangent of an angle is the opposite over adjacent, and op over ADJ is fine. And that's the formula. Write that every time so that the tangent of 20 degrees is side A is 12, and adjacent, opposite over adjacent, the adjacent side to angle A is B. And then rearranging, multiplying both sides by B divided by tangent 20. Now you can see right here, B is in terms of everything that's given, 12 and 20, right? So no approximations there. And then it's going to be 33.0. So I'm putting this in because someone said, oh, I want to do this or I want to do that. I want to use the Pythagorean theorem. Okay, but you may not use that B is 33.0 because B is not 33.0. It is close to that. B is 12 over tangent 20 degrees. So if you're going to insist on using B, then you're going to have to write B as 12 over tangent 20 degrees, right? So that A squared plus B squared equals C squared. C squared is A squared plus B squared. C squared is equal to plus or minus that. And note, everything that I'm calculating is given. A is 12, 12, and 20. And then I give the proper approximation. And of course, the length of C is not a negative number. So I have 35.1. And then finally, I have that in a right triangle, the two angles that are not the two acute angles add up to 90 degrees. So B is 90 degrees minus A. And I'm been a little sloppy there, but there it is. So I'm going to do. I will probably get through this one. I will get through this one, and then I will stop and post this, and then no, or maybe yes. Okay, and then I'll do another one. All right, so now I'm given two sides. How do I then find all three angles and the other side? Note, I've said I want an exact answer. So again, uppercase Roman, uppercase Roman, uppercase Roman. C is the right angle. The square indicates it's the right angle. Side A, opposite angle A is 4. Side B, opposite side angle B. Side B, opposite angle B is 7. All right, now I am going to use the Pythagorean theorem. And so observe that everything in the calculations is given. That is absolutely known, or without approximating, it's simply taken as given. C squared equals A squared plus B squared. And there's a 4 given, 7 given. Square plus or minus the square root of 65, positive square root of 65. Done. No approximation, exact answer. All right. Now I need to find angle A. All right, so the tangent of angle A, again, why did I pick tangent? Because these two are given. So it's opposite and adjacent, opposite over adjacent. So the tangent of angle A is opposite over adjacent, and that means that A is tangent inverse of A opposite A over B, and that's the tangent inverse of 4 over 7. And I just press that in my calculator, and inverse tangent goes between negative 90 and 90 degrees. In a right triangle, the inverse trigonometric functions all work because all of the angles are between 0 and 90 degrees, and the range of all of the, well, of sine inverse, cosine inverse, tangent inverse is between includes 0 to 90 degrees. So we're good. You may say, so 29.7, round to the nearest tenth. So you may say I'm violating what I've done here. Yes, in some respects, I probably should have then, to find b, calculated b as the inverse tangent of 7/4. But the three angles do have to add up to 180 degrees. So no matter what happens here, I'm going to get 60.3. All right, here's what I'm going to do. I'm going to pause this. No, I'm going to stop. And then I'll do the other two problems. Give you a chance to work on them also.